The power supply unit, or PSU for short, is an essential component of the computer configuration. It converts high voltage alternating current from the wall outlet into low voltage direct current required for the functioning of all computer components. While it does not directly impact performance, the PSU plays a crucial role for the overall system stability. Just like motherboards, the PSU has a standard for the dimensions called form factor. The most common size is called ATX or ATX PS2 and fits in standard cases ranging from full tower to mini tower. For smaller PC cases, you might also find options like TFX, SFX and SFXL. The most important parameter of a PSU is the power rating measured in watts. A higher power rating allows for more powerful components to be used. Some PSUs also include several protections, such as overvoltage protection, undervoltage protection, short circuit protection, overpower protection, and overtemperature protection. These protections either shut down or limit the PSU to protect itself and the other components, therefore increasing the reliability and longevity of the whole computer system. Based on the input voltage, we can divide PSUs into three types. The fixed input voltage. These work only with a specific voltage level, for example 230 volts at 50 Hz. Second, the manual voltage selection. These power supplies include a mechanical switch on the back to select either 120 volts or 230 volts. And third are the automatic voltage selection. Modern PSUs like this one are designed to accept a wide input voltage range, from 100 volts up to 240 volts, with a frequency from 50 to 60 Hz. To meet the needs of different devices, the PSU delivers various voltages: 3.3 volts, 5 volts, 12 volts, and minus 12 volts. The 3.3 volt rail powers devices that comply with the CMOS logic levels, while the 5 volt rail powers the USB ports and the TTL logic devices. The plus 5 volt standby rail provides power even when the computer is turned off, enabling features such as Wake on LAN and Wake on USB, and allowing USB ports to be used for charging. The 12 volt rail supplies power to high demand components like the CPU and the video card. The minus 12 volt rail was previously used to power serial ports, while nowadays primarily serves as a reference voltage and power to integrated circuits that require differential voltage. The current and the maximum power for each rail are usually printed on a label on the side of the power supply case. If power values aren't listed, they can be calculated by simply multiplying the voltage by the current. The sum of all individual power rails should be greater than or equal to the PSU's total rated output. If the sum is lower, however, you're likely dealing with a wall quality PSU that cannot reliably reach 100% load. Based on the cabling type, power supplies come in three variations. First, the fixed cables, also called non-modular. Second, the semi-modular. And third, the modular, which is also called fully modular. The non-modular option has all the cables permanently attached, and no cables can be added or removed, or at least without disassembling it. This usually means that you will have at least few cables just hanging around that you need to hide somewhere. On the other hand, it provides simplicity for beginners, and it is the cheapest option overall. The semi-modular option includes the essential cables such as the 24-pin ATX connector and the CPU power connector attached as fixed cables, but also has additional ports for adding PCI Express power cables, SATA and Molex connectors when it's needed. The fully modular power supply doesn't have any fixed cables at all, and instead comes with different ports in which you can plug in only the cables that are needed by your configuration. It is the most flexible and most tidy cable management option at all. However, this also is the most expensive option, and it usually costs around 30% more for the same parameters compared to the fixed cables option. The connectors of power supply include several types. First, the motherboard connector, usually 20 plus 4 pin. It is also called ATX power connector. The CPU power connector, also called EPS connector, which can be either 4-pin or 8-pin. The 8-pin connector can also be split into 4+4 connector for backwards compatibility. The PCI power connector, usually 6+2 pins. It is used to supply power to the GPU. Although it looks similar to the CPU power connector, the pinout and shape of certain pins differ, preventing incorrect insertion. Typically, PCI Express and CPU connectors are labeled for convenience. The SATA power connector. It is a 15-pin flat connector which is used to power hard drives and SATA SSDs. And the Molex connector, which is used for powering older hard drives, case fans, and legacy devices like optical disk drive or floppy drive. For all those cable types, excluding the ATX power connector, power supplies can have multiple cables, for example 2x8 pins for the CPU. Additionally, some cables, like the SATA power, can have multiple connectors along the length of the cable, allowing you to connect multiple devices with a single cable. However, keep in mind that some cheaper power supplies might not supply enough power for more than one drive with the same cable. On some PSUs, you might encounter the label 80+. The 80+ standard ensures that the power supply meets a certain minimum level of efficiency. Initially, this was set at 80%, but as power supplies have become more efficient, additional certification levels were added, such as bronze, silver, gold, platinum, and titanium, each representing progressively higher efficiency. The standard defines minimum efficiency levels for 20, 50, and 100% loads. Typically, more efficient power supply units are more expensive. However, if the computer is used throughout the entire day on a daily basis, a more efficient unit could save you money on electricity over time. And finally, to calculate the total power your configuration needs, use the following formula: the CPU max power plus the GPU max power plus 20 watts for each hard drive or SSD plus 50 watts for other peripherals. Then multiply that sum by 1.25 and select a power supply that meets or exceeds that value. For more complex systems, you can also use a PSU calculator tool available on the internet. My advice to you is this: never go too cheap on the PSU unless you're on a very tight budget, especially if you rely on your computer for work. Getting a PSU from a reputable brand like Seasonic, Corsair, and Be Quiet might save you a headache. Some models come with up to 12 years of warranty. A high-quality, powerful enough power supply can even be reused if you decide to upgrade your configuration in the future. Thank you all for watching. If you liked the video, please give it a thumbs up and make sure you're subscribed to my channel, as more exciting videos are on the way. See you soon!